Okay, so solving quadratic inequalities, we're going to look at graphically first. So it says we ought to want to know when a function takes on values that are blank, blank, or blank. So we want to know where functions are positive, where functions are negative, or where they are equal to 0. All right. So where are they positive, where are they negative, where are they equal to 0? And in particular, at 0 places where you're changing from positive to negative. So if anything, that's probably the most important. That changes to. All right. So that's what we've done in the previous classes. And then we talked about we have 5 different ways of finding zeros of functions. Find them graphically, right? Figure out where it's crossing the x-axis. Those are your x-intercepts. You can find it by extracting roots, factoring, quadratic formula, complete the square. So you have 5 different ways of finding zeros. So graphically, you can find this or identify this by looking at the graph in comparison with the x-axis. All right. So if we're talking about where is a function greater than, right? I know you know these inequalities, so greater than, right? Graphically, that's going to be where is it above the x-axis. Less than is going to be where is it below the x-axis. Exactly equal to would be on the x-axis. And then what would you say graphically for greater than or equal to? Do what? Just combine the two things, right? So if it's greater than or equal to, then it's above or on. Just combines the two things. So greater than or equal to means above or on. Less than or equal to means below or on. Okay, and then reporting your answers, usually you're going to use the interval notation again, but you will use the inequality notation some as well. So we need to be able to use both of those forms and kind of be able to go back and forth between the two. Okay. So then our first example, right, the graph is provided for you, so it has the equation underneath there. It's in its root form, so we have f of x is equal to x plus 3 times x minus 2, right? Which means we have x-intercepts or roots at -3 and at +2. So those are those 2 points that are graphed for you on there. And then it gives you a various set of inequalities. So where is this function equal to 0? That's where it's on the x-axis. So that was at x equals -3 and x equals 2. Where is this function greater than 0? So that's the above part. So that's the red part of the graph, since it's got red and blue split. So where is it above the x-axis? If you wrote that as an inequality, right, it would be where is x less than, what is that, -3? Which would be this part over here. Or where x is greater than 2. So we have those two pieces that are separated. As an interval notation, right, that would be -infinity to -3 or 2 to infinity. Right? So those are those two notations that you need to use when you're reporting. You're talking about function values. You're giving me the x values, right? So where is the function above the x-axis for these values of x? Right? And then C goes from greater than 0 to greater than or equal to 0. So how is my answer for C going to differ from my answer to B? So we're both talking about greater than 0. So what changes from B to C? Do what? What about it? It's still going to be less than, but now it's less than or equal to -3, and then that's going to change the interval to brackets. That's the big change you're going to see, right? So if we go from less than to or equal to, then now we can have the bracket around those zeros, right? So it's still x is greater than or equal to 2, so or 2 to infinity. So And then same thing happens on the less than part. Now we're talking about the blue, right, below. It's below the x-axis between these two values. So now I don't need to have two separate inequalities. It's between -2, or sorry, -3 and 2. So -3 is less than x is less than 2. You could write it as a compound inequality when you're between two values. If you wrote it as two separate, you would say x is greater than -3 and x is less than 2. But it's just easier to write a compound inequality, put the x between the two boundaries. And then as an interval, that's from -3 to +2. In parentheses, because we don't want to include the zeros. And then in E, when it changes to or equal to, right, -3 is less than or equal to x. It's less than or equal to 2. So -3 to 2 in brackets is the change there. Okay, so solving algebraically. Right, so now we don't have a graph to rely on, so we can find the zeros ourselves. We just talked about the different ways. Right? All of those methods depend on the fact that you have a quadratic function that's in standard form, so it must be standard form. And then we want it to be equal to 0 or compared to 0. Right, because now we're going to have inequalities, so it could be less than 0, greater than 0, etc. We want it to be compared to 0. So all of these, so ax squared plus bx plus c, that's the standard form. We want that to be compared to 0. So greater than, less than, or equal to 0. All right, and then we're going to find these zeros. Talk about the different methods of doing that. If you need to relist them over there, relist your methods. Okay. So that is just taking what we've done the last week and applying it to today. The new part for today is going to be, this step 3 is going to be create a sign chart. And then once you have the sign chart, should be step 4, right, is going to be basically reading your sign chart to determine which intervals belong in the solution. Okay, so again, if we're greater than, we're looking for where is the function positive. If we're less than, we're looking for where is the function negative. If we're or equal to, we're greater than, positive, or equal to 0. And then less than would be negative or equal to 0. And so a sign chart is essentially going to be a number line. We're going to find our two zeros or find our two roots. It's a generic root 1, root 2. And then that's basically breaking up your number line that goes from -infinity to +infinity. And then you're going to check each interval. So you pick any number that's in between -infinity and positive, or not positive, -infinity and root 1. Determine what the sign is, and we'll just say this ends up being positive, this ends up being negative, this ends up being positive. Right? And then once you have a sign chart, you've checked a number in each interval, then you can determine what the solution is. Okay? So in the first examples here, these two are already, half the work's done for you. So again, when we see something that's in this factored form, don't try to multiply it out. You're just creating more work, right? So it's already compared to 0, so that's a good thing. So we need to find the zeros of this, which would be x equals -4 or x equals 1. And then I'm going to create the sign chart. So I'm going to put those two zeros on the number line. It doesn't have to be perfectly to scale, right? But it does have to be the smaller number to the left, right? So -4 and then +1. You don't have to go through and go -3, -2, -1, so on and so forth. That's not necessary for our purposes. We just need those two numbers on the sign chart in order from least to greatest. Okay, and then you're going to check a number in each interval. So pick any number that you want that's something in between -infinity and -4. Negative what? 10? Yeah. So 10. I'm going to write the number on here that we're checking. If you want to check a different number, then check a different number. And then you're just going to do what you did on the bottom part of that warm-up. You're going to, what is the value of this function, which this is our function that we're talking about. That's our f of x. What is the value of that function when x equals -10 or whatever you picked, right? So I would say -10 plus 4 times -10 minus 1. That's what, negative 6 times negative 11? What does that equal to? 66. Okay. We're doing a sign chart, so we don't really care that the value is 66, because if I picked negative 10, but somebody else picked negative 5, which would still be between those two values, you're going to get different numbers here. You're still going to get the same sign, right? You should always end up getting, in this case, a positive answer in that interval. No matter what you picked for x from negative infinity to negative 4, you would end up with a positive result, because it would be a negative something times a negative something. Yeah. And then between the two numbers, again, the assumption is, because of the quadratic, right, we talk about the graphical shape, it goes down and it comes back up. So we're anticipating it being that situation that we saw graphically. So then the assumption is, yes, in between, we should probably anticipate it being negative. Doesn't hurt to check, right? So a number between negative 4 and 1. 3 does not work. Negative 3 works. I would check 0, right? But anything in there, right? So that becomes, if I plug in 0, 0 plus 4 is 4. 0 minus 1 is negative 1. That's 4 times negative 1, which is negative 4. So it happened to be what we thought it would be. Some people doing the sign charts just put the signs all across the top and bottom, or across the top. If it's negative, I put a negative sign below and then circle it. Right? It's kind of a personal preference, but you'll see it both ways depending on who you talk to. Are you done?
No.
Oh, you bringing me a snack too?
Yeah,
Oh, somebody already brought me one.
sorry, get you another one.
You said sorry, get you another one.
Yeah.
Okay. So if I plug it in 2, I would get 2 plus 4 times 2 minus 1. So it's 6 times 1. We don't really care about the value. We just care it's a positive times a positive, so that interval ends up being positive. All right. So you have a completed sign chart. Again, a lot of this extra work down here is more mental math than anything. Most of those you'll be able to check, right? We just care about positive times positive. Okay. So we'll do an abbreviated sign chart in the next example. But then the last part of it is, now that I have a sign chart, I need to answer the question that was asked. I'm saying, where is this function less than 0? So which intervals do you want? Less than 0 means negative. So then my answer is negative 4 to 1. So I'm going to squeeze that up here. So negative 4 to 1. It's less than, so it's just going to get parentheses instead of brackets. If it was greater than, then you would take the positive intervals. So it just depends on what is the inequality that you're trying to answer. Okay. So if I do the same thing on the next example, a little bit more abbreviated, again, I'm already compared to 0, so I don't have to do any of the initial work. So now we're looking at where is it greater than or equal to 0. So this is going to be positive or 0. You want to make note of that before you start doing a bunch of other work. It's already factored, so I'm not going to multiply this one out either. So I'm going to create the sign chart again. So my critical numbers, or my zeros, are going to be at x equals 2 and x equals 5. So make sure we put those on there in numerical order. And then I need to check an interval, or check a number in each interval. Really, you only have to check one interval, and then we can alternate. So what number do you want to plug in? 1. So if I plug in 1, 1 is between negative infinity and positive 2. So in this first interval, I'm plugging it in. All right. Negative 1 minus 2 is negative. All right, it'd be negative 1. And then 1 minus 5 is also negative. So this was an abbreviated sign chart. Okay? And if I have any negative factor times another negative factor, you're going to end up with a net result of a positive in that interval. Okay? And you can do the same thing. Pick a number between 2 and 5. 3. If I plug in 3, 3 minus 2 is positive, 3 minus 5 is negative, so I have a positive times a negative now in that interval. So that interval is negative. Okay, so that interval is negative. Oh, the pen. And then if I pick any number greater than 5, whether you wanted to do 6, or you wanted to do 10, or you wanted to do 1 million, it doesn't really matter, right? Just pick something, and then I have, can't plug in 5, because that's going to be the 0, so I got to be something between 5 and infinity. So 6 minus 2 is positive, 6 minus 5 is positive, so positive times a positive means that interval is positive. Right? So then my answer, reading the sign chart, I want to know where is this positive or equal to 0, right? So it's positive from negative infinity to 2. And now because I can be equal to 0, I can include this in a bracket instead of a parentheses. So the 2 gets a bracket now because it's equal to, and I can keep it. If it's not equal to, parentheses, right? So negative infinity to 2 or 5 to infinity. So in this next example, x squared plus 8x plus 7, it's already being compared to 0. So I can go ahead and find these zeros. I'm just going to hold on to that. Okay, so if I try to factor, are there factors of 7 that combine to be 8? If so, then we can factor it. If not, then quadratic form to complete the square. So I can factor this by doing 7 times 1 is 7, 7 minus 1, or sorry, 7 plus 1 is 8. So then I can factor this. My factors would be x plus 7 times x plus 1. So then my zeros that I'm going to use to create the sign chart are negative 7 and negative 1. So I'm going to put those on the sign chart. Negative 7 has to go first. And then pick any number that you want to check in any interval. Just make sure when you pick your number that you're choosing an interval or putting in the right interval. So if I wanted to just go left to right, anything between negative 7 and negative infinity, so negative 8. If I plug in negative 8 to the factored form, it's going to be easier to check the sign than it is to the original. All right, so if you are able to factor it, do your sign chart in the factored form. So negative 8 plus 7 is negative 1. Again, I just care that it's negative. And then negative 8 plus 1 is negative 7. And I just care that it's negative. So no matter what I chose in that interval, I would get something negative times something negative. So I would have a net positive result in that interval. Okay. And then because this is a quadratic function, at this point, you kind of like Norgie said earlier, we can anticipate what's going to happen next. What's the next interval going to be? Negative. And then the last interval is positive. So again, we're just, every time we do this, we're abbreviating that sign chart a little bit. And there's nothing wrong with doing that. So we just, the only problem with doing that method is if you get the wrong answer in the first one, all of them are wrong. So just be really sure you get that first interval correct. And then you can alternate with the exception of you ever have a double root where your vertex is on the x-axis, then that causes a separate issue. Okay? But that's not going to be very common. All right, so we have the sign chart, and then we can go back and answer the question, where is this function greater than 0? So then we're saying, where is this positive? So it's positive from negative infinity to negative 7, parentheses, because we're not equal to 0, or negative 1 to infinity. Same thing on the next example. We're already compared to 0. This time we're doing less than or equal to 0. You find the zeros first. So if I can find factors of negative 16 that combine to be negative 6, then I can factor it. If not, then I need to do a quadratic form to complete the square. I can use negative 8 and positive 2. So then my factors are x plus 2 and x minus 8, which means my critical numbers, my roots, are negative 2 and positive 8 for my sign chart. check a number in that first interval, so anything between negative infinity and negative 2. Most people just go to negative 3, but if you wanted to do something very negative 1,000 or something, you can. And then do my sign analysis. Negative 3 plus 2 is something negative. Negative 3 minus 8 is also negative. And if I have a negative times a negative, I would get something positive. And because we know enough about quadratic functions, we know it's going to alternate, decrease, increase. So positive, negative, positive. And then I can answer the question that was asked, where is this function less than or equal to 0? So that is, where is this function negative? It's negative between negative 2 and 8. And because it's or equal to, I use brackets instead of parentheses. So the next one, x squared minus 13x is greater than 30. I want this to be compared to 0, so I'm going to subtract 30 first. So x squared minus 13x minus 30 is greater than 0. And then now I know I'm trying to answer where is this function positive. And so I can do a sign chart. If I can factor, are there factors of negative 30 that combine to be negative 13? Negative 15 and 2. Okay, so then I can factor it. My factors end up being x minus 15 and x plus 2. So my roots or my zeros are at positive 15 and negative 2. So if I do my sign chart, I'll pick any number less than negative 2. So negative 3, plug it in. Negative 3 minus 15 is negative. Negative 3 plus 2 is also negative, so that interval ends up being positive. And then we can alternate. And then I can answer the question that was asked, where is this function greater than 0? It's greater than 0 where we are positive in our sign chart. So from negative infinity to negative 2, not including negative 2 because we're not equal to 0. Or 15 to infinity. Okay. We'll skip x squared plus 7x, but I do want to do one more down here at the bottom when a is not equal to 1. So we'll do 2x squared plus 5x is less than negative 2. Start the same way by adding 2. Now we're compared to 0. So we're trying, where's this function less than 0? So in our sign chart, it's going to be where's it negative? Okay. Are there factors of 4, 2 times 2, that combine to be 5?
4 and 1.
4 and 1, so then we can factor it. When this a value is not 1, you have to do one additional step. What is that one additional step? Make the fraction thing shortcut, or you can do, instead of doing x times x, it would just be 2x plus 4, 2x plus 1, and then one of those two, sometimes both, but one of those two will have a common factor that you could take out. So if you don't like the fraction thing and you can never remember which one goes with x and which one doesn't, this is the same basic process. You just have to take the GCF out. So this factor becomes x plus 2, 2x plus 1. Because we introduced an extra 2, so that extra 2 comes out for something. It's the same thing as writing the fractions, reducing the fractions. If that way works for you, then stick with what's working. Okay? So my factored form ends up being this. So my zeros are negative 2 and negative 1/2. So my sign chart, negative 2 would come before negative 1/2 on a number line. And then I need to check an interval, or number in the interval between negative infinity and negative 2. So negative 3 again, or anything else. Negative 3 plus 2 is negative 1, so negative. And then 2 times negative 3 is negative 6, plus 1 is something negative. So I end up with that negative times a negative again, which is positive. And we can finish the shine chart by alternating. And then I can answer that question, where is this function less than 0? It's less than 0 where it's negative, so between negative 2 and negative 1/2, not including, because it's not equal to 0.